Hello students, today we are going to study the basics of OOPS under the programming paradigms. So what is object-oriented programming? Object-oriented programming or OOPS refers to languages that use objects in programming. Object-oriented programming aims to implement real-world entities like inheritance, hiding, polymorphism, etc. in programming. The main aim of OOP is to bind together the data and the functions that operate on them so that no other part of the code can access this data except that function. The basic OOPS concepts are as follows. So here after, like in the following slides, we are going to cover about class, objects, data abstraction, encapsulation, inheritance and polymorphism. We will not go into the depth, we are just covering the basics of the concepts. So first, starting with class. A class is a user-defined data type. It consists of data members and member functions which can be accessed and used by creating an instance of that class. It represents the set of properties or methods that are common to all objects of one type. A class is like a blueprint for an object. Now coming to an example. Consider a class called student. Now there may be many students in your class with different names and roll numbers. But all of them will share some common properties, right? Like all of them must be studying in BCA, First A, KJC. So you have some common factors, right? Coming to the second concept, that is object. Object is a basic unit of object-oriented programming and represents the real-life entities. An object is an instance of a class. Each object contains data and code to manipulate the data. For example, here I have taken the name of a student, which is a real-life object. So that student exists in real life and has values for name, roll number, etc. So as discussed previously, class is the blueprint and object is an instance of that class. So here student is the blueprint and the particular student is actually the instance of that class student. Coming to the third concept, that is the concept of data abstraction. Now, data abstraction is one of the most essential and important features of object-oriented programming. Data abstraction refers to providing only essential information about the data to the outside world, hiding the background details or implementation. Let us consider a real-life example of a person who is taking a cab. We all take cabs in our day-to-day lives, right? Now, the person who is taking the cab or the car will just know that the car is a mode of transport or communication which can take him from one place A to the other place B. But he or she does not know about the inner mechanism of the car. That is what your abstraction is. In the next diagram, you can see it's a very classic example of abstraction. I have two pictures in this. If I ask you, what is this in picture number 1? You will just say that it's a car and it takes us from place A to place B. In the second picture, however, my dear students, we can see that the car has been, I can say, like deassembled, right, by a person who is probably the mechanic. So to a mechanic, the car is not only a mode which can transport him from place A to place B, but it is a combination of various parts, right? We can see, right, that he's carrying his tools and he's actually, opening all those parts or, deassembling all those parts from a car. So it depends. Going back to the basic definition, It provides only the essential information about the data to the outside world. It hides the background implementation. So we as passengers, we only need to know what is the uh, functionality of that particular car. It can take us from place A to place B. But as a person, as a mechanic who is expected to know the details about the parts of a car, for him the car is not only a mode of transport but more than that. We are now coming to the next concept of object oriented programming, that is encapsulation. Encapsulation is defined as the wrapping up of code and data that it manipulates under a single unit. In encapsulation, the variables or data of a class are hidden from any other class and can be accessed only through any member functions of that class in which they are declared. As in encapsulation, the data in a class is hidden from other classes, so it is known as data hiding. You can see a diagram below that. It shows a similar shape as that of a capsule which we consume as medicine. So inside that capsule we can see variables and data which are bound together in the form of a capsule, and it is called a class. So it is also a form of data hiding. Coming to the next concept, and a very important one of object oriented programming, it is inheritance, and it is a very important pillar of OOPS. The capability of a class to derive properties and characteristics from another class is called inheritance. So when we write a class, we inherit properties from other classes. When we create a class, we do not need to write all the properties and functions again and again, as this can be inherited from another class that possesses it. So what is the basic fundamental advantage, you can say, of using the inheritance? So I have a class, okay, I have a class called animal, okay. So all the animals have many features, right? Many features, like what is their color, what is the way they make sound, okay, a number of legs, okay. Now under those animals we have child classes, like variety of animals, like suppose dogs and cats. So dogs and cats both are coming under animal class, and they have features of their own, right? So what do we like, thinking technically or in terms of a programming language, inheritance will allow the user to reuse the code whenever possible and then reduce the redundancy. So for animal, we can write a separate class. We can write separate classes for dog and cat without inheriting any properties or functions from the animal class. But then we have to write the complete class again. Instead of doing that, we are just inheriting from the class animal, and trust me, it's an easier way to do the same thing. Coming to the next property, that is the property of polymorphism. Now the word polymorphism means having many forms. So in simple words, we can define polymorphism as the ability of a message to be displayed in more than one form. For example, a person at the same time can have different characteristics, right? For example, consider a man. At the same time, he's a father, he's a husband, he's an employee, right? So the same person possesses different behavior in different situations. That is called polymorphism. For example, how do we think about it, shifting a bit to the technical side of that? Suppose we have the operator plus, okay? That particular operator plus normally is used to add two numbers, right? Now suppose I have two strings, okay? Two words. I want to add, or I want to concatenate, or I want to join those two words. Can I use plus? No, right? But I can programmatically give a new meaning, or an additional meaning, I should say. additional meaning to the operator plus, so that other than adding two numbers, it can also join two strings. So, what am I actually doing here? I am giving a new meaning to the operator plus so that it does something extra other than just adding two numbers. So, I think now it is clear to you. Like at the same time, the operator plus has different characteristics. Either it is, adding two numbers, or it is joining two strings. So, why do we need object oriented programming? To make the development and maintenance of projects more effortless, to provide the feature of data hiding that is good for security concerns. We can solve real world problems if we are using object oriented programming, because in many of the cases we see that object oriented concepts are much more realistic and much more nearer to the real world problems. It ensures code reusability. Just now I have shown, or I have explained to you the concept of inheritance. It lets us write generic code, common general code, right, which will work with a range of data, so we don't have to write basic stuff over and over again. Thank you, my dear students.